In this video we're going to look at the discriminant. So the quadratic formula, as you should know, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The b squared minus 4ac is what we call the discriminant because it will determine how many roots this has. Roots is another word for solutions. If the b squared minus 4ac part is positive, so just pretend it was something like 9, you get the square root of 9, which is 3. So then on the top line you'd get minus b plus 3 and minus b take away 3, and that gives you two different answers. So if the b squared minus 4ac part is bigger than 0, you get two different real roots. Okay, so you get two unique or two different real roots. Now if the b squared minus 4ac part is equal to 0, you get the square root of 0, which is 0. And then you get minus b plus 0 and minus b take away 0. Now they would both be the same answer. So you would get two of the same answers. Okay? So if b squared minus 4ac is equal to 0, you get two repeated real roots. So you get the same answer twice. Okay? And finally, if the b squared minus 4ac is less than 0, so in other words, if you were in the square root of a negative, at C1 or this level, you can't do the square root of a negative. You try and your calculator gives you a math error. Therefore, you can't work this out, so it has what we call no real roots. Now, if you're doing further maths, you'll find out that you can't no real roots. If you're doing further maths, you'll find out how to get the imaginary solutions to this. But at this level, b squared minus 4ac, if that's negative, you can't square the negative, so therefore this is no real roots. Let's have a look at what the discriminant means in terms of the quadratic graph. So if you had a quadratic ax squared plus bx plus c, and you were drawing that graph, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant, and you would work out the discriminant, you would find that if it was positive, so b squared minus 4ac, and is positive, you would find that it has two different real roots, so it would cross the x-axis at two different locations, like so. If you do the discriminant on a quadratic b squared minus 4ac and find it was equal to 0, you'd find that the quadratic touches the axis, the x-axis, and then goes back up again like so. And if you were to do b squared minus 4ac and get that that's negative, there'd be no real roots, so what you would find is that the graph wouldn't touch the x-axis. It would be above the x-axis like so. Okay, let's have a look at some exam questions. So, here we've got the equation x squared plus 3px plus p is equal to 0, where p is a non-zero constant and it has equal roots. Find the value of p. So firstly, in a question like this, let's have a look at what the information we've been told. We've been told it has equal roots. That means that b squared minus 4ac equals 0. Next, let's have a look at the quadratic, the equation, and let's identify what a, b, and c are. So a is the coefficient of x squared, which is 1. b is the coefficient of x, so the thing in front of the x is 3p. And c is the constant on the end, which is equal to p. So what we get is we get b squared, well, it's going to be 3p squared, make sure you put it in brackets, minus 4 times a, which is 1, times c, which is p. And that equals 0. So let's square it. So we're going to get 3p squared is equal to 9p squared, subtract 4p. And that's equal to 0. Next, what we're going to do is we're going to factorize this. So let's take out our p. So we're going to get p bracket 9p subtract 4 is equal to 0. Now, two things that multiply together to give you 0. So either p is 0, so either p is equal to 0, or this bracket 9p subtract 4 is equal to 0. Bringing the 4 over will give you 9p is equal to 4, and dividing by 9 will give you p is equal to 4/9. But we were told in the question that it is a non-zero constant. In other words, p cannot equal 0, so that means that our answer would have to be 4/9. Okay? So that's the question, which is a typical discriminant question, and because it said equal roots, we had b squared minus 4ac equals 0. You label your values for a, b, and c, you put them in, and you solve it. For our next example, we have the equation 2x squared minus 3x minus k plus 1, all in brackets, equals 0, where k as a constant has no real roots. Find the set of possible values of k. Now, before you watch this, watch the rest of this video, I'd recommend you watch the video on solving quadratic inequalities and the importance of sketching curves for that. So, first of all, we know that the question says it has no real roots. That means that b squared minus 4ac is less than 0. Okay, A, B, C. A is equal to 2. B is equal to negative 3 or minus 3. And C is equal to minus k plus 1 in brackets. So minus k plus 1. Another way of writing that also would be minus k minus 1, expanding your brackets there. Let's substitute these into the discriminant. So we have got minus 3 squared, subtract 4 times 2 times c, which was equal to, well, let's use this version, minus k minus 1. And we know because it has no real roots, it is less than 0. So expanding this, or working this out, will give you 9 subtract 8 bracket minus k minus 1 is less than 0. And expanding this then would give you 9 plus 8k plus 8 is less than 0. 9 plus 8 is equal to 17. So you get 8k plus 17 is less than 0. Bringing that over would give you 8k is less than minus 17. Dividing by 8 would give you k is less than minus 17 over 8. Apologies, at the beginning of this I said you needed to look at the video on the quadratic inequalities. You didn't need to know that for this one. Let's have a look at our next example. Okay, our next example says the equation x squared plus kx plus k plus 3 is equal to 0, where k as a constant has different real roots. In other words, it's got two distinct roots, different real roots. So we know that b squared minus 4ac, b squared minus 4ac, because it's got different roots or two distinct roots, is going to be bigger than 0. It then says show that k squared minus 4k minus 12 is bigger than 0. So let's work out what the discriminant would be. So a is equal to 1, b is equal to k, and c is equal to k plus 3. Let's substitute those in. So b squared is equal to k squared, subtract 4 times 1 times k plus 3. And that is bigger than 0. So what you would get there is k squared minus 4 bracket k plus 3 is bigger than 0. Let's expand the bracket, so you get k squared minus 4k minus 12 is bigger than 0. And that is what we were asked to show. So QED. Okay, B. Find the set of possible values of k. So for this, it's very useful to draw a quadratic graph, okay? So because we're trying to solve this quadratic. So let's sketch the quadratic graph. Let's find the critical values where it crosses the x-axis. So we have got k squared minus 4k minus 12. And we want to find where it crosses the x-axis, so let's just put it equal to 0 and factorize and solve it. So we get k, and we would have plus 2 minus 6 equals 0. So k is equal to minus 2 and k is equal to 6. Let's just check this. So k times k squared, k times minus 6 and k times 2 would add together to give you minus 4, and 2 times minus 6 is minus 12. So we know it's going to cross the x-axis at minus 2, and it's going to cross the x-axis at 6. So that's what the quadratic is going to look like, or the graph of the discriminant would look like. So draw it like so. We're trying to find the values of k, or we're trying to find when the discriminant is bigger than 0. Okay, so whenever this would be bigger than 0 would be whenever the graph for the discriminant is higher than the x-axis. So it would be this part and this part. Okay, so we have found that k is bigger than 0, or this k squared minus 4k minus 12 is bigger than 0 whenever k is bigger than 6, so whenever k is larger than 6, or this way, whenever k is less than minus 2. So our answers would be, to find whenever this graph is bigger than 0, you have got whenever k is larger than 6, or whenever k is less than minus 2. So to find the set of possible values of k, the answer would be, k is less than negative 2, or k is bigger than 6.